guys, it's Mrs. Jackson. Today's video is going to walk you through how to predict products for very simple synthesis and simple decomposition reactions. So as we get started, you're going to need these items available. Be sure you've got your periodic table of elements that has the chart of ions on the back. You're going to need your notes because you're going to want to copy down the examples, and your thinking cap. You shouldn't need a calculator today, but you will need the remaining items on this list. So be sure you've got those out ready to go before you continue on with this video. One of the things I want to remind you of is that there are some elements on the periodic table that when we write them by themselves, they have to be written as what we call a diatomic element. And the word diatomic, if you break it apart, the prefix di means two. So when I'm looking at my word, this means two. And then obviously atomic sounds like atom. It's part of the word right there. So diatomic elements have to be written as a two-atom molecule. So these 7 elements that we have right here are the only 7 elements that we write this way. Now there may be others that also get subscripts when they're by themselves, but for this course, this year, those are the only 7 that you need to know. Most teachers will just say this as if it's a word, and we just say Brinkelhoff. But the elements that make up Brinkelhoff are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Any of those 7 that wind up by themselves have to be written with this subscript 2. They have to have 2 atoms together in order to be stable. So keep that in mind as we go through some of these very simple practice problems. The first thing that I'm going to show you are simple decomposition. And when I say simple, what I mean is these are going to be binary compounds. These are only going to have 2 elements. So the simple ones that you're going to be responsible for will only have 2 elements, and what you will do is break those into the 2 elements that you see. So for example, on this top problem, I've got water. So I know that this is going to be decomposition because I only have 1 reactant. So we are going to break it apart, and when I do, I'm going to break it into the 2 elements, hydrogen and oxygen. But then I have to remember that hydrogen and oxygen are both part of my diatomic elements, so each one of those will have to have the 2 written next to those. Both of those would be gas. They would break apart into gas. Then you could go back and you could balance the equation by putting a 2 here and a 2 here, and that would balance your reaction. I have 4 hydrogens here. I've got 4 hydrogens here. I've got 2 oxygens because it distributes, and then I've got these 2 oxygens here. For the second example, I've got sodium iodide is going to break down. Again, this is decomposition because I only have the 1 reactant present. So it's going to break down into the 2 elements, and the 2 elements are going to be sodium. So I have Na, and I'm going to have iodine. So I'm going to write my symbol for iodine. But again, when I go back and I look at Brinkelhoff, I find that iodine is one of those special 7 elements that have to have a 2. So I'm going to come along and put my 2 next to the iodine. Sodium, our Na down here at the bottom, sodium is not on my list of 7, so it does not get the 2 subscript. Leave it as it is right here. Then if you want to go back and you want to balance it, you need a 2 in front here, and you'll need a 2 in front here. And that's going to give you 2 sodiums, 2 iodines, 2 sodium, and 2 iodines. So that's really all you're going to do for the simple decomposition reactions. The next that we need to look at are going to be simple synthesis. So I know that these are simple synthesis because I only have elements. Okay? Potassium is an element, bromine is an element, and the only thing you can do with 2 elements is to bring them together. So this is going to look very similar to the decomposition, except it's in reverse. When you have synthesis reactions, the one thing that you need to keep in mind is you're only going to have 1 product. And these are going to be very simple, as the title here states, very simple binary compounds. Binary means two, so I have two element compounds. All of these that you look up, or all of these that you write, are going to be ionic. So they will have a metal and a non-metal. So when you write the products for these reactions, you're going to write your element, and then you're going to look on your ion chart, and you see that potassium is a +1 ion. Then you're going to have to find bromine on your ion chart. When you find bromine on your ion chart, it is only Br. When you look in the bromine box, it's just a Br with a minus. Notice that I did not bring this 2 over. The 2 is only here because bromine is alone. On this side of the reaction, bromine won't be alone. It's going to be with potassium. An easy way to help you remember is when you look up the bromide ion on your chart, it only says Br. It doesn't say Br with a 2. So you just write the symbol as it appears on your chart. Once I have this written, then I can do the crisscross and reduce. So I bring a 2 down, or 1 down here, I bring a 1 down here, and my final compound formula is going to be KBr. If I want to balance it, then all I would do is I would come back and I would need a 2 in front here, and I would need a 2 in front here to balance. The second, or the reaction below, is again another simple reaction. I've got aluminum reacting with oxygen. Aluminum is not on the list of Brinkelhoff, so it's Al by itself. Oxygen is on my list of Brinkelhoff. Right here, oxygen is on my list, and so I write it is written with a 2. When I go to predict my products, I have to look up these elements, or these ions on their chart. I'm going to have one product because it is a synthesis reaction. When I look up aluminum on the chart, aluminum is written as Al, and it has a 3+ charge. When I look up oxygen or oxide on my chart, you'll notice I don't bring that 2 over. Again, that 2 is only there because he's alone on the left side, but on the right side, he's going to bond with the aluminum. When I look up on my ion chart, the symbol for oxide, it's an O by itself with a 2- charge. Once you have the charges written, then you can simply crisscross and reduce. I bring a 2 down and I bring a 3 down, but a 2 and a 3 don't reduce. So your formula is simply Al2O3. So that's how you predict the products for the simple decomposition and simple synthesis reactions. Now that you've finished your notes, please go in and do the practice set of 10 problems following the examples I've given you here. Don't hesitate to reach out with questions if you've got them. Thanks, guys. Bye.